Combine like terms. Example 1. Simplify the following expression. So you can see that below we have 5 different terms, and they're all different based upon if it's either x or x squared, because these are 2 different things. Even though they have the same base of x, one is raised to essentially the first power and one is raised to the second power. So we can only combine the ones that are the same. So this 1x and this minus 6x can be combined together. And then this x squared of that 7 can be combined with this 6x squared and this 3x squared. So let's do the following expression where we add those together. So we have 1x minus 6x plus, then we're going to add these together, 7x squared minus 6x squared plus 3x squared. So now we've rewritten all these terms in a way that we know that we need to add everything inside these parentheses as they are similar, as in they have the same variable at the end. So 1x then minus 6x is essentially all we're doing is going 1 minus 6. So 1 minus 6 is equal to negative 5x plus, then we're just looking at the numbers now. So 7 minus 6 is equal to 1. 7 minus 6 is equal to 1 plus 3, which is equal to 4. And then we then go x squared. So notice that we did not do anything with the x squared. We didn't add x squared together because the only thing is that we're saying that they're notice we didn't do anything really with the x squared. We just left the number in the front and then we made it x squared, or in this term we just made it x, because essentially what it is telling us is that we have 1x here and then we have 6 x's here that are all negative. So notice how we just added the numbers together. We left the variable at the end, and then that would be our solution to this answer. So we have minus 5x plus 4x squared. And it doesn't matter if you put in the 4x squared first or the minus 5x, but as this would be the same if you wrote it like this, which you can do either in WAMAP, as both are the same answer. So let's do another example. Nathan owns 4 different auto shops. He needs to do some inventory in all the shops as he wants to ensure the numbers on the computer are correct. So for quarts of oil, he uses an O, and for oil filters, he uses an F. Shop 1 has 1,127 quarts of oil and 50 filters. Shop 2 has 54 O and 35 F. Shop 3 has 141 O and 177 F. And then shop 4 has reported 85 O and 140 F. So remember that like terms can be combined when they are the same. So what we're doing is we're going to add then all the O's together. So what we're doing is we're going to then add all the O's together and all the F's together. So let's go ahead and circle all the O's. And then we're going to box in the F's. And now let's go ahead and write this all out. So we have 1,127. Then we have 54. Then we have 141 ohm. And then we have 85 ohm. And we're adding all these together, and they're all positive because it's inventory. Now let's go to the F's. So we have 50 F, 35 F, 177 F, and 140 F. So let's add all these together. So we don't do anything with the variable O or F. So let's just add the numbers together. So we have 7 plus 4, which is 11, plus 1 is 12, plus 5 is 17. So we put a 7 below, and we carry that 1. Now we have 1 plus 2, which is 3, plus 5 is 8, plus 4 is 12, plus 8 is 20. Put a 0 below, carry the 2 over. 2 plus 1 is 4. And then we just have the 1. So then, therefore, we have 1,407 O. Just make sure that's an O, not a 0. So I don't want that to be mistaken. Then let's add all the F's together, which is the filters. So 0 plus 5 is 5, plus 7, 12. Carry the 1. 1 plus 5 is 6. 1 plus 5 is 6, plus 3 is 9, plus 7 is 16, plus 4 is 20. Put a 0 below, carry the 2. 2 plus 1 is 4. And then that is F. So then we combine them, and we would say we have 1,407 quarts of oil, which that's why we have the O, plus 402 filters. So this would be our final solution.